Hello everyone, so now is the time to deal with this threading thing in here. So I told you that this only works because we have allowed main thread queries in here, which is not acceptable in production. So now if you remove this and run, let's just confirm that our app will crash. So let's see. Okay, so it says that can't access database on the main thread since it may potentially lock the UI. So that's the main reason why we don't anyway use queries on main thread. So how we fix this issue? So if we go to repository, so this is the critical part, and also this one where we save the data. So easy solution is to say new thread. We specify runnable and you say start. So we just basically move this part of code there, and we repeat the same thing in here. Let's run the app now and see the result. So as you can see, it works now. There is no issue, but the question is this approach the best? So it may be easy, but it's not the best approach. So why is that? So every time we say new thread, we are basically spawning new object, which is thread, and it will take additional half up to 1 megabyte of memory of our RAM. So practically every time this thread is spawned, we are consuming our RAM memory more than we need it to maybe. And if user press this button a lot of time, it can spawn just enough threads so that our app crashes due to out of memory issues. So to prevent this, we need to somehow keep our number of threads fixed. So we don't want every time somebody calls this method, we don't want every time thread to be created. So what we want to do actually is to reuse threads. So let's undo this in here. So what we want to do is to use executors. So we will create a new class. We will call it executor supplier. Now what we want to do, firstly let's make this private. We don't want this class to be instantiated. Now we want to have singleton of executor service executors dot new fixed thread pool, and for the number of threads we usually limit to number of cores. So in Android we can simply say runtime get available processors. So in most of the cases on Android devices it will be 4, maybe up to 8 on some high-end devices. We want to get this service like this. So now in repository, instead of spawning a new thread, we will just say executor supplier dot get instance dot get execute, and here for the runnable we put our logic. We can use lambda in here, so Android Studio suggests that. And we will do the same thing in here. So let's firstly run the code so that we can confirm that the issue is gone with this approach as well. Okay, so it's working perfectly. So now what is going on in here actually? So we have created pool of 4 threads, for example, in our case, because I checked available processors on this emulator is 4. So we have 4 threads. If the user click several times to get pictures, we will use, for example, thread number 1. If the thread number 1 is occupied, we will then use 2nd, 3rd, 4th. If all threads are occupied, we will not be spawning more threads, but there will be a queue. So we will be waiting for some thread to be available so that it can pick up a runnable task so that it can be executed. So this way we have prevented creation of unnecessary threads, and we will be only using up to 4 threads. So in this way our application will be resistant on out of memory issues, and it will be working smoother because we are not consuming more memory than it is supposed to. So now when we figured out this issue about threads and we solved it, let's continue on with UI implementation. We will do that in the next video.